What is up, people? In today's video, I'm going to show you guys one of the most simplest solutions to one of the most complex problems in performance engineering, and it's called mocking. Let's go. So what is mocking? Mocking concept is very simple. Imagine we have a system called foo and we have another system called bar. Now foo is dependent on bar. It makes an API call. Bar is running in the cloud, or it is built by an external party or another team in the organization. Let's say we don't have much control over system bar. Now, mocking is the concept of simulating the behavior of a real system in a controlled way. So we can achieve mocking by building a simulated version of bar, and then like as a dummy system that behaves like the real thing. So let's say we want to test foo in isolation without depending on bar. We can build a little mock system that simulates the functionality of bar, and then that'll allow us to continue development on foo and do testing in isolation. So there are a couple of scenarios under which a team would require a mock. Now the first one is, let's say system foo is under heavy development by your team, but system bar is not available yet, and the developers of system foo might decide to build a mock server for system bar because it's not available yet. It might be an external team, another company building it, but they have the API contract. So that's one use case. Use case number two could be that bar has a really high cost to call. Let's say it's a payment gateway, or let's say the provider of system bar is charging a couple of cents per API call. The problem there is that, let's say system foo has a couple of hundred automated tests, and these tests run every day, or hundreds of these tests run per day. You might want to mock out system bar under that case. So in certain cases it may be wise to use a mock server. Now the third one, and this is the one important one for this topic, is performance load testing. Now when we want to test how system foo behaves under load, we also want to ensure we're not affected by the performance of system bar. We also want to make sure we're not testing the performance of system bar. Instead, we want to isolate it by introducing a mock server so that we can just understand how our code performs on system foo. Now let's talk about the common mistakes. In my experience, mocking is probably the easiest part of performance engineering when done right. Otherwise, it's probably one of the most complex. First mistake is teams assume that a minimalist style hello world, very small bit of code type of mock server can handle load, and 99% of times in my experience this is false. It will not work. Now similarly, reason two, and this is the reason, is that people assume that the default runtime, so let's say you use Java, Node.js, Go, .NET, they assume the default runtime can handle high performance, and this is not the case, because when these runtimes ship, the default configuration for these runtimes are generally set to a kind of a basic sort of trade-off. So where they consider security, they consider memory usage, CPU, garbage collection, all these type of settings to basically tune it for just like a standard default configuration. The thing with mock server is we want to throw all of that out and sacrifice everything so that we can get high volume, high throughput, low latency to basically simulate an environment. Now the good news is that these runtimes are configurable. Most teams don't realize this, but you can change the configuration options to tune things like inbound max connections, outbound connections, also the timeout settings and things like that. So those need to be taken into account when creating a mock server. Number three, teams often do not test their mock server. They create it and then they jump straight in and test their initial server. The big thing I'm stressing here is that you should always test your mock server. When you build a mock, make sure your mock server can handle more load than your actual application. Right, now before I show you guys the code, you might be asking, why am I going to use Go? Now there's a couple of reasons why I use Go and not a proxy server. First of all, it's extremely simple. It's easy to read, it's easy to learn and modify. The other thing is it has extremely low overhead, so very similar to a proxy, they get similar amounts of requests per second. It performs extremely well. The third reason is certain proxies need custom modules to do certain things, whereas Go, you can achieve similar thing with just like one line. So you'll see in my mock server today, I'm going to build a mock that has a latency, so it simulates a latency by doing a sleep, and it's like just one extra line of code. So let's break down the code. Now you're going to need 4 things. The first thing you're going to need is Docker. If you have Windows, Linux or Mac, go ahead and install Docker, and then we're going to go ahead and create this Docker file. Now the Docker file here, I'm going to show you very quickly. We're building using a Golang image. We go and install Git because that's where our dependencies are. We then pull in a web server and a logging library using go get, and then we run go build after copying our source into the Docker image. We then use a very tiny Alpine image to copy out our mock binary after the build has been successful. And here we copy in our mocks. Now in my case here, I'm just going to use a JSON API as a mock server. So I'm going to copy in some JSON file. You can copy any file you want to mock. So it could be HTML, it could be XML. And then I'm exposing port 80 and I start up my mock server. Okay, the third thing you're going to need is this tiny Golang file. Now we start off package main, all the defaults, we import a bunch of dependencies, we have a byte array to keep our mock, so we read it once. A lot of mistakes I see people make is they actually read their mock from disk on every request, and that generates a lot of system IO and makes it slow. So we have a main function, we read our mock from disk once, we populate it in a variable, and then we start up our router. Now this path, I'm just serving it as slash. If your API you're trying to mock has some kind of a path here, so let's say it's some PayPal gateway or something you're trying to mock, you can just fill out the path here, and you can also change the router type to post, to get, whatever it is you want to mock. And then we start our web server on port 80. It's as simple as that. I also have a file here, just the example JSON file I grabbed off the internet, and that's what I'm going to respond with. Now you can get the real response from your system, and you can put that in here. And as I said, this can be XML, HTML, anything. Now I will place a link in the description to a blog post that I created that has all these files in a GitHub gist, so you can just copy them all out and you can just run all these same steps to generate a build. Now one thing to note here is I have this function called mock, and in here I basically just write a standard out to say, hey, I've mocked. You don't have to do that. I also set the content type, and you can add any content type you need here to simulate the API you're calling. And I do the sleep of 700 milliseconds because the API I test might have an average response time of roughly 700 milliseconds. So I want to simulate that using sleep, and it's as simple as this. Now to build the mock server, once you go to my gist and you grab all the files and you have them in the same directory, you run this docker build -t with the name, and I'm just going to call it my mock. So let's run that build. Right, so now that that is built, I'm going to do docker run -d for background mode, and I'm going to run it on port 80, and that's my mock image. So let's go ahead and run that, and we can see if I do docker ps, our mock server is running right over here. Now I created this other Alpine image so I can go ahead and test this, and if we switch over to that, we can see I do this curl to that mock server and I just give it a hello, and it will respond with my mock, so we can confirm it's working. So now that our mock is running, I wanted to show you guys this really cool tool. It's on GitHub. It's called Wrok, and it's an HTTP benchmarking tool to test performance of HTTP web servers. It is a really awesome tool. I'm going to use this one to just quickly show you guys a test. So the first test I'm going to do is running a load test on the mock server without any sleep. So I commented out the sleep line, and let's just see how far this goes. Now remember, I'm running the load test on the same box as the mock server, so it's not ideal. I'm going to be bound on network sockets. So if you're running it on separate servers, you probably get more throughput, but I want to show you really how well this performs. So let's take it for a spin. Now here I do docker run. I mount in my local directory because I have a test in here called post.lua that has just like a hello message I want to post to localhost where the mock server is running, and we're going to spin up 4,000 connections here. That is about the limit because I'm running Docker on Windows. It's a tiny virtual machine, so we're really a bit constricted as to how far we can push this. I'm using 10 threads and I'm going to run this over 10 seconds, so let's give that a go. And we can see this performs really well for a tiny little virtual machine. I'm getting 20,000 requests per second, so that is the capacity. I did bump it up in earlier tests, but I wasn't able to get more out of it because it's all running on this little virtual machine. I don't have a lot of capacity, and 20,000 is pretty good. So let's bump up the sleep and run another test. Okay, and here are the results. Now again, it's a tiny machine, so we got to be a bit gentle on it. It has 600 requests have timeout, but we got a 6,000 RPS throughput on this. We can see here we're running a latency of 500 milliseconds and roughly average of 44 milliseconds on top of the 500 millisecond sleep. So yeah, that's how we would run a mock server. Now if you run this on separate machines, you'll get a much better response time. I think I was able to get this on an Azure machine. I was roughly getting about 10 to 15,000 requests per second by separating the mock and the load test. Remember, on the same box, the load test tool will compete for sockets. So always good to create two separate boxes, run the WRK on a separate machine, and run the mock server so you won't see this kind of contention. Yes, I hope that was useful to you guys. Remember to check out the link down below for the blog post so you can grab these files, give it a spin, and let me know down in the comments if this helped you. And yeah, peace.